I'm pleased to come here to give a talk. And after a very theoretical analysis about the GenAI, you see this is really, really theoretical. So I tried to give you a more relaxing material about what is really the large language models and how can we contribute to the current state of art or construction of large language models. So Xiaogang and me are both from CHK, so you can imagine how strong the AI researchability of CHK is. Okay, just for kidding. So first, I will give you some background about what is really the deep learning and large language and vision models. So human brain. So I give you some context. So human brain. So what is really a human brain? So this is our biological construction instead of the machine structure of the human-made objects. So in human brain, there are more than 86 billion euros, B4 billion, billion euros. So the neuron here, so it's not a very big number. So if you like a number here, so you may know if you have any knowledge about current large language model, you realize. So today's large language model easily reaches more than 1,000 billion parameters. So does it mean that the computer is already more powerful or superior to the human ability? The answer is no. Why is no? Because every neuron is not work by its own. It has synapses. Synapses is another kind of connection. It's like a human hand, so connected to others. So when I'm a neuron here, so I have a hand, I will touch the other neuron. So the hands. How many hands for each neuron here? So the number is surprising. So more than 7,000. So that means every neuron has more than 7,000 hands to touch each other. And if we multiply the number here, so 7,000 times the 86 billion, so we have, so the total number of parameters in human brain is about 700 trillion. So this is the actual number about the parameters for human brain, for every human brain. Everybody sitting here, and you should be proud because you have more than 700 trillion neurons in your brain. And I give you a number. So if you don't quite understand this number, I give you a comparison. So do you know the GDP of China in 2022? The whole country. The GDP of the whole country of China is about 121 trillion RMB. So that means this number is already 6 times larger than the total GDP of the country of China. This is just a background. So I give you some background, so let you know that actually, so we still have a very long way to go. If we talk about human biological thing, and there's another fact. I see some boys and girls here. So if you don't understand this clearly, I can give you an idea. Say when you find a kid at 6 is super naughty. If he's super naughty, this is not because he's naughty. It's because at that time he has the most synapses and neurons in his or her brains. And when he grows up, more and more neurons will be cut out from the brains because they are useless. And then slowly, so when we grow to 20 or 30, so we get a stable number of all the neurons in our brain. And then when we go to the 60 or 80, so we get a minimum number of neurons in our brains because we're getting old, so a lot of neurons are died. This is the general process of human biology evolution. Now, this is artificial neural network. So it's you look at this table, you feel like this. Okay, it's similar. So we try all the ways. So try all our best to make the artificial neural network similar to the human brain neural network. This is what we did. And it turns out it's very successful, and it proves very effective in finding some great solutions. Now, I can show you this figure here. So in past 20 years, so the size of neural networks determines the ability, and this is some facts. So when we just use hundreds, thousands of different parameters in our artificial neural network, we find the computer can only do some very simple recognition, like a handwriting recognition or face recognition. So this kind of a very simple thing. But if we increase the total number of parameters into millions, then we found, okay, suddenly systems is capable of doing face recognition, target detection, semantic segmentation, complex class classification, so on and so forth. So it's kind of already amazing. But in past 5 years, people realize if we do large model, so that means use tens of billions of parameters, then we achieve qualitative change. And this qualitative change is showing on the right figure. So it's more like when the kid is growing up, and in year 1 he or she knows nothing, and year 2 almost nothing, and year 3 almost nothing, and suddenly in year 4, year 5 he becomes an artist. And this is a change. This is what we observe from the artificial neural network in past 5 years. And when we use tens of billions of parameters in this machine brain, and we realize this machine suddenly becomes an artist. And it started from almost nowhere. And today he understands almost everything. Here is another example. I showed it in past situations, in other scenarios. So if we use just the 3 billion parameters to ask the system to write a Q data structure using 2 stacks in Python. So this basically means I ask the system to write a program, right? So this is write a program. And if we use just 3 billion parameters, so this is the answer. So this is the answer the system returned to us. So basically it tells us, okay, you create 2 empty stacks and then create a new Q data structure by pushing elements. So it's, it's not what we want, because we wanted the code, but this is not a code. Okay, I increased into 30 billion parameters. That means I increased the total number of parameters by 10 times. Suddenly it gives us the complete code. And there's no any gap between it. That means there's no anything gradually increasing thing, no such thing. This is emergence. This is called emergence. Suddenly it is capable of giving you the complete code without any error. So this is what we found in past days. And also this is another example showing by GPT-4. So basically if you ask system to draw a dog, okay, he can draw a dog like this one to you. Okay, this is a JavaScript, a dog. But if you ask system to write a dog using SVG, then you see this output the code. And if you run the code, and you find, okay, so the code output such a figure, and this figure is more like an abstract dog, and this is the SVG programming language, and you can imagine. So basically, this GPT-4 may not know what is exactly the SVG produced drawn dog, and he can imagine. So this is dog you want. All right, this is called imagination and connection. So what is the current progress of a large language model? It's interesting though globally. So we found the GPT-4 by OpenAI has reached more than 1,000 billion parameters, and GPT-5 has been trained over 30,000 and 50,000 H100 GPU cards. And in academia, so we have Llama and Llama 2, and in China, you see you have more than probably 100 companies has products in different large language models. So on the right, you see there are some claim is already useful, almost useful, decided when to useful, and I'm not sure when to get produced. So this is just for fun. But actually, so that means we have really a lot of companies working on the large language models. Then, so the large language model. So how can we evaluate the large language model? So today, so if you look at GPT-4, so basically it contains more than 1,000 billion parameters, and its storage capacity is equivalent to tens of millions of books. What does it mean? So how do you understand this figure? So if we talk about the National Library of USA, and this is the largest library in the world, has more than 180 million books, but GPT-4 contains hundreds of such libraries. So this is the total number of knowledge that current large language model has learned. And this is a huge knowledge. And I believe in the next 5 or 10 years, and there will be no knowledge in human history ever created to learn by machine, because all the knowledge has been learned by machine. There's no knowledge anymore. This will happen in the next 5 or 10 years. Then I also give you some other facts. So this is interesting facts. So GPT-4 was trained on by a leaking message. It's not formally announced. I'm not sure this is the correct number, but I just guess it's almost this number. So these are 25,000 A100 cards for over 3 months. It costs $900 million if purchasing the hardware. So that means anyone want to reproduce the GPT-4, okay, at least you need to have, in the first place, you need to have $900 million to buy the hardware. Then you need probably another hundreds of millions of US dollars to hire the person to do the deployment. So it's very, very expensive. And even using the OpenAI cloud, training cost will be $63 million. That means if I don't buy the hardware, okay, then you can hire. So you can hire or you can rent some machines from a cloud. It also costs you $33 million. It's still very expensive. And there's fact interesting I give you. So according to the GPT paper, so this is a paper from GPT, and an engineer ever discovered a data division bug. I mean, this is something wrong. I mean, this bug during training. But because this is so expensive, and even the OpenAI cannot afford a retraining system, so they choose to take a turnaround to let the bug exist there, because it's too expensive. Okay, so this is something you can find from the formal report from some papers. Now, so given that we have this fact, so I go to my own research, so I can share you something more interesting observations from the large language model. First of all, we talk about the limitation of current large language model. Although this is very expensive, it's very powerful, and people think that it may be capable of doing everything, but the fact is no. It's not a all around. It's not a super person. It's not a super computer. It still has some limitations. First of all, it is not very good at reasoning by rules. This is I give you an example. So basically, if you ask the question, say, I want to calculate the root of 2. This is the root of 2 here. So you can basically see the answer is correct. The root of 2 is 1.41421356, right? So this is correct. So then you can imagine saying, okay, giving this answer, I imagine that the system already learned the rules. I mean, how to calculate the square root, right? So you may think it's this way, but the fact is not. If you ask the similar question, say, to calculate the root of 5,768. I mean, this is just a change a number and follow the same rule, and the system should give you the correct answer also. But the result is not correct. So there's something wrong in the result. It means what? It means sometimes you really don't know how the large language model learned the knowledge. I mean, some knowledge are learned in a very strange way. Probably the square root of 2 is learned by remembering the result. And then if you ask the question about the root of 5,000 or something, then the result is wrong, means that it does not know the rule by itself. Okay, so this is the first limitation. The second limitation is not very good at the long conversation. So if you're using the GPT-4 today, you can have some conversation. But if you keeping asking questions and let it go on, then you find that after 10 conversations So the GPT-4 already forget the early conversations. Already, he does not remember what you talk about. I mean, just 1 minute ago. And so this is called a forgetting. This is a conversation forgetting problem. And after 20 conversations, I mean, you see here, you see the last part. So after 20 conversations, the system says, okay, the conversation is too long. Please start a new one. So that means he cannot continue anymore. It's so exhaustive for the computer. All right. So that means the second limitation is that it's not very good at a long conversation. The third, of course, the third is the question problem is that it cannot answer very long questions. So if you input a book, I mean, you can ask questions normally. I mean, this is no problem for the GPT-4. But if you input a book, I mean, a fiction or academic paper or whatever, a long book, then the system will say, okay, if I ask the system about a three-body problem, and by inputting a book with more than 30K tokens into the question, then the system will go wrong. I mean, it gives you irrelevant answers because it cannot understand all the tokens. And also the Llama 2 is an open source large language model, and this is give you even the wrong output. Say, model does not support a context size greater than 4,000 tokens. Expect poor results. So this is the third limitation. And finally, I think we should let the system to know our visual world. I mean, currently we believe that language model is language, and the language cannot be connected very well to the visual world. So the large language model cannot understand visual information pretty well. So if you input an image, a photo into the system and ask the system to describe this photo, say you see the result is rely on the imagination instead of the real photos input to the system, because this is some kind of poor connection between the language and the visual systems in the current machines. But it's changing now. We have the GPT-4V. This is already very powerful, but we still have found a large room to get a further improvement. So I give you a few interesting findings from my own research. So first work is to contribute to answering very, very long questions. So this is really our first work. So this work is called LongLLaVA and LongLLaVA. This figure tells you this is the alpaca, but it has a long neck, so it's called a LongLLaVA. LongLLaVA is a model, so this is a new model. And this new model is very powerful. Why we call it powerful? Because I can give you some facts. First of all, there's an article just published just recently saying revolutionizing language models, LongLLaVA, unveiled as a game changer for efficient text sequence processing. So this is a comment from other experts in the AI area. And our code is already published on the GitHub, and it's top one trained on Hugging Face and a paper with code. And this is already received about more than 180K views on Twitter for this work, and it is more than 1K GitHub stars in just 1 week. So I just want to show you how interesting this work is. And what this work is about. Here I give you a few examples, and these few examples are really interesting. I can show you. So I will slow down to let you know the exact the consequence about using such a model. So here first of all, below is a paper. Memorize the paper and answer my question after reading the paper. And this paper is shown on the right, and it contains more than 15,000 tokens. And then for other large language models, they cannot process this paper because this is too long. And so if we want to further improve, then the question is based on the review guideline, because every conference has a review guideline. So please provide me some suggestions that would make the paper has more chance for acceptance. Okay, so the paper is so that means we ask the system to take the role as a reviewer to review the academic submission. So this is not achievable traditionally because the paper is too long. So here, our system will give us some very useful suggestions. First of all, the first suggestion is to clarify the contributions and the novelty more precisely. So this is pretty good suggestion, and we know this is the problem when we submit the paper, and he clearly indicate that the system already found this problem. The second, provide more experimental details and results, and also it gives all the details following this sentence. Interesting. And the third suggestion is to discuss more potential applications and future directions. And this will increase the chance to get this paper accepted. And this is the three suggestions. And after the suggestion, we improve the paper and submit it to the conference, and it is accepted. So that means the system works. It's really useful. And this is just one example. Maybe this may not be very close related to some of you here, but I have more interesting examples. So this is analysis about economy, our economy. So below is economic outlook. Memorize the content and answer my questions of the book. And this book is Global Economic Prospects. It contains more than 42,000 tokens. And based on the material and your understanding, please predict the economy in the future. Okay, so that's a really tough task, right? So because the system has to read the whole book analysis and then predict what our global economy will change. And then the answer is here, is also listed here. I give you a few highlights. So based on the economic outlook from 2006 to 2023, here are my predictions for the global economy in the future. First, growth will remain moderate and uneven across countries, with advanced economies like growing faster than emerging markets and developing economies. So this is the prediction made by the machine based on reading such analysis in past 15 years. So based on the 15 years economy change, it gives the first prediction. So growth will remain moderate. Yes, from the end, this is already the end of 2023, and we notice that this is true. The second, inflation will remain elevated, but start to come down from the high level seen in 2022 and 2023 as central banks continue to raise interest rates and commodity prices stabilize. And this is the second prediction. And from today's point of view, yes, it is still elevated, but it come down in terms of the speed, right? And the third one, the recovery from the COVID-19 pandemic will continue, but likely remain bumpy. So that means recovery will happen, but the process will be bumpy. And as new variants emerge periodically, and this is the prediction, third one. And the fourth one, downside risks will continue to outweigh outside potential. So that means there are still a lot of risks from the economy. And this economy, this kind of the risk going down economy is outweighed outside potential. And this is the trend prediction. And today you see, giving this year's the total performance of the economy market, we notice this is very correct. Then the structural reform will be needed to boost the productivity, supports inclusive growth, and facilitates transition to a green economy. And finally, central banks will gradually normalize monetary policies, but remain cautious and data dependent. Okay, so these are the few comments and prediction, and based on the economy. Okay, so that means after reading the book, you don't really need to read by your own. You just rely on the machine and input the book, and the book will be read by the system successfully, and you will get all the essential information that the system can tell you. The third, another example, following by another example. This is the fiction, 西游记. Below is some section from the book, 西游记. Memorize the book contents and answer my question of the book. So 孙悟空present undefeated strength when causing havoc in heaven, while he was later defeated by many monsters during the journey to the west. Why? Right. So this is a very interesting question. Say, 孙悟空was very powerful. I mean, when 大闹天宫, right? Then later on, when he go into the west, I mean, he become weaker and weaker. So what's the reason? So the system gives us some answers. Very interesting. He was still maturing. Okay, so when we get a material, we don't fight. So we argue with people, we don't fight, right? So this is the first reason, and it's very interesting. So when we get a material, so we sell them, we try to find other ways to solve problem instead of fighting, right? So this is the first point. The second point, he faced a stronger opponent. So when he was in heaven, so do some kind of rampage, then you can imagine. So everyone is trying to protect himself or herself, and then when we try to face the monsters try to keep alive and keep a forever life. So this is totally two different situations. So that means he faced stronger opponents. We're very correct. And the third fact is they face the restrictions. All right. So when Sun Wukong was in heaven, there's no any restriction. But when he get on the road, I mean, then with the Buddha, with Tangsen, he has restrictions already. And also trickery. So because the monsters during the road are smarter than those 神仙 in the heaven, because they have different ways to trick the Sun Wukong, right? So and also he need to help from others. So because today, so the Sun Wukong has some fellows. He has Tangsen, he has other fellows, and he has to take care of. So that means he cannot put all his efforts to fight the monsters. Otherwise, the Tangsen will disappear, right? So this is also this happens a lot during the role. So this is the analysis by this book, and the systems give you perfect answers. And so in summary, a combination of Sun Wukong's maturity and stronger components, restrictions on his power, deception, and lack of companion initially contributed to his defeat during the journey. But over time, he gained wisdom. He knows that he don't need to fight so hard. And experience and comrades that helped him to eventually overcome even the most formidable foes. Okay, so this is the answer. So basically, I give you for a few examples. So this is my science fiction about the three body. So this is my favorite book, science fiction. And so this question is why Ye Wenjie can contact aliens, and then why did he feel regretful in the end? I mean, anyone read this fiction, science fiction? I mean, this is really, really a good one. If you didn't, you should immediately go back to find one book, and this is an amazing book. And so the reason say ideally he wants to bring a superior alien to civilization to help fix humanity problem. Okay, so this is the first reason. So it's very correct. The second, for revenge. She wants to get revenge on humanity for persecuting her and killing her father. So because her father was killed by the Cultural Revolution. So because he has a kind of feeling of revenge in the beginning. So this is why he bring the aliens into the earth. So this is in the beginning. And then, however, in the end, she seems to regret her actions because, first of all, he realized that potentially bring alien inventions, he had endangered all humanity. So this is not to help the human. It's to evacuate or eliminate all the humankind. So that means he feel regretful. And then as time passed and the society seemed to be improving with the advent of science and the rationality again, he found that humanity is not a problem that cannot be cured. Maybe human can cure by themselves. And after seeing humanity, the capacity of both the culture and kindness during her time with the villagers, her views on humanity becomes more nuanced. Okay, so this is a few answers from that book. So basically, I give you this example show you that we have a very useful, powerful, long context large model. This is open source already, so you can use it by your own, and you can use it as an interface to incorporate it into your research or work or whatever kind of things you need to do. I think I should stop here because my time is over, but I prepared a very long talk here. I have other talks I originally want to show you, but okay, I leave it to next chance. Okay, you will have a chance. Thank you.